might be wondering why I'm sat in the door of a plane strapped to someone who can only be described as a madman. Frankly, at this moment, I was asking myself the same thing. I'm Ross, and this week we're exploring the science of skydiving. So how is it possible to jump out of a plane and survive? Gravity is a pretty powerful force, and 15,000 feet is a long way to go before hitting the ground. We've all experienced gravity. What goes up must come down, and it's a product of the object's mass. This apple and the Earth are both being attracted towards one another because of the force of gravity. But since the apple is far less massive than the Earth, the apple appears to fall towards the Earth. The acceleration due to gravity is 9.8 meters per second. In other words, with each second that passes, I'm going to be traveling 9.8 meters per second faster. But this doesn't mean that I'm going to keep speeding up until I hit the floor with a splat. So here I have a giant fan and a smoke machine. Now, if I take this inflatable shuttle and place it in the stream of air, we can see that it flows over it very easily. So there's not much air resistance there. But if we switch this to something with a bit more surface area, we can now see the air is a lot more turbulent and is facing greater air resistance. This air resistance is what's going to help me survive the jump. As I fall through the air, it's going to be pushing back on my body in the opposite direction. And the faster I fall, the greater the force of air resistance pushing back. After 3 seconds, our speed is already at 60 miles per hour, but air resistance is already affecting our acceleration. By 8 seconds, we're at 102, and it takes a further 7 seconds for us to reach 120 miles per hour. At this point, the force of gravity is equal to the force of air resistance. This means that we've stopped accelerating, and so our speed is constant. This is called our terminal velocity. This belly down position also helps increase air resistance. But even so, hitting the ground at 120 miles per hour is still a very bad idea. The instructor has already released a small parachute which helps create a little extra drag. When we get to roughly 3,500 feet, the instructor deploys the main parachute. All of a sudden, the huge surface area massively increases the air resistance and we quickly decelerate. In just a couple of seconds, we go from 120 miles per hour to just 5. And I've got to tell you, that's the biggest wedgie you can ever experience. After several minutes of gliding around, we land safely back on Earth. For more science stunts, why not watch me walking across red hot coals? Stay tuned over the next few weeks as we'll be investigating all things foodie, from beehives to milking cows. So for more science every week, click subscribe. Thanks for watching.
When a skydiver jumps out of a plane at 3,000 meters, her speed goes through some big changes. So what's happening to the forces as you fall through the air? The force of gravity is always trying to pull us towards the Earth. Before the skydiver jumps, the floor of the plane provides a counterforce which balances the downward force of gravity right up until the moment she steps out. Gravity immediately pulls her towards the ground, and she starts to accelerate downwards. But air resistance is acting in the opposite direction. The faster she falls, the greater the air resistance. Eventually, the upward force of the air equals the downward force of gravity. When forces are balanced, the speed remains constant. That doesn't mean she stopped falling. It means she stopped accelerating. She's still doing a steady 55 meters per second, and hitting the ground at this speed isn't a good idea. To slow down, the upward force needs to be greater than the downward force. When the parachutes open, air resistance suddenly becomes much greater than gravity. The forces are no longer balanced, and this changes her speed. She slows down. Because she's slowing down, air resistance decreases until it balances gravity again, and she reaches a much slower constant speed. Approaching the ground at 5 meters per second is a much better idea. As she hits the ground, there's a thumping great counterforce from the Earth, which decelerates her very quickly. So for skydivers to land safely, they need to understand forces and use air resistance to slow themselves down.